Next method will be conversion from decimal to binary, which is second method, LCM method. This method is same for every conversion from decimal to octal, decimal to hexadecimal. The first example we'll be discussing is 3. 3 to the base 10, and we have to convert it to the binary, which will be here. I have mentioned in the LCM method, while doing LCM, we have to divide the dividend, which is 3, which closes to the dividend, and take the remainder after dividing. Whatever the remainder will be there, we have to keep that on the right side of the divisible number. And in this example, you can see 2 into 1 is 2, and the remainder is 1. So we're giving the remainder 1. And if the value given here at the end, if it is lower than the base, we end here and we count from bottom to up. In this case, x will be 1, 1. Similarly, we can discuss another example in binary. We are taking 6 to the base 10 and we are dividing the number closest, that will be 2 into 3. And remainder is 0. We'll be keeping that in the right side. The base value is lower than the number which we have to divide. So we have to continue again. Now 2 into 1 is 2 and the remainder will be 1. We are keeping that in the right side. Similarly, we will be counting from below or bottom to up and we get x as value 110. And here this is base will not be 10 because I have represented it as 2. I mistakenly wrote here 10. This will be 2. Next will be decimal to octal, which is the same method, but we'll be taking few examples so you will be not having any doubt. The example is 7 to the base 10, which we have to convert to base 8. And here the number is 7. 7, which we have to convert to octal. What I have told at the starting is octal, which represent number from 0 to 7. So we don't have to divide or take any LCM of it. The value will be straightforward 7 in this case. And next example is 18 base 10. We have to convert it to octal. And here, similarly to the binary, similar to the conversion from decimal to binary, here the base is 8. So we'll be dividing with 8. 8 into 2, 16. Remainder is 2. We keep it at the right side. We get 2 at the end, which is lower than the base value. So we will end here. We will taking from down to up, which will be 2 and 2. 22 is octal number. Similarly, to convert from decimal to hexadecimal, it is similar to the conversion from decimal to binary and decimal to octa. But the only difference here will be the numbers which we are representing. We had to represent 10 to 15 from A to F. This is the only difference in this for hexadecimal. First example will be 67. We have to convert it to base 16. We take the LCM method. We multiply with 4 and we get a remainder 3. So we will be putting this 3 on the right side. We'll counting from bottom to up. This will be 16 base 43 value. We take another example. We are dividing 168 with the base 16 and multiply by 10. The remainder will be 8 and 10 is lower than the base 16. We end the LCM here and you can see we had to represent this 10 as 8. If we want to, you can put 1 0 and 8, but logically it would be wrong, because when we are saying the number loud like 108, is it actually 108 or is it actually 10 and 8? So we cannot represent this while adding 1, 0, and 8. So we have to convert from 10 to 15 into alphabet, so there will be no confusion. It will be starting from A, then B, C, D, E, and we end with F at 15. So with this, we end the conversion from decimal to hexa or octa or binary.